Hello everyone, and welcome to another webcast in our Transform Your Business webcast series. Today's webcast is Avoid Mistakes in SCADA Projects. Use Asset Organization to hyperscale your application. Before we get started today, just want to go over a few housekeeping rules. My name's Amanda Gordon. I'm the Senior Marketing Programs Manager here at Iconics, and right now on the webcast, you are in a listen-only mode. That means if you have any questions throughout the webcast, feel free to type them into the questions section of the GoToWebinar panel, and we will answer those at the end of the webcast. You may also email them to webcast@iconics.com, and we can email you the answers offline as well. Now with that, let me introduce you to our presenters today. We have two presenters. Both are from different offices. We have Ziwei Li, who is the Director of Innovation and Incubation Solutions, who is in our headquarters in Foxborough, Massachusetts. His email is here as well. And we also have Roberto Raimondo, who's Iconics Italy Managing Director, and he's in our Italian office. And here is his image and his email as well. And with that, I'm going to kick things off and turn things over to Z.
Thank you, Amanda. Welcome to the webcast today about hyperscaling your applications. The agenda for today, as shown, we're going to talk about the comparisons between traditional configuration methods, modern configuration methods, and the products that Iconics has that allows you to take advantage of the modern configuration methods and to hyperscale your application. And then we'll end with a demo that Roberta will show, which shows the power of the applications, allowing you to scale your production. So a little bit about Iconics today. We are a Mitsubishi Electric Group company. We have been in business for 30 years. We're in hundreds of countries with over 400 partners, and we have 375,000 installations and counting worldwide. We're very closely aligned with Microsoft, and we have been awarded the Microsoft Gold Partnership and 6-time Partner of the Year awards. We span businesses from smart buildings to manufacturing intelligence, industrial automation, power, water utilities, oil and gas, and public infrastructure. So our software is used to power significant amounts of business in the world, and we enable digital transformation. Industries that we find ourselves in are in automotive manufacturing, building automation, food beverage, military, government, manufacturing, oil and gas, materials mining, pharmaceutical, sustainability, transportation, utilities, energy, and water. So we have a very wide breadth of industries that Iconics is in, and that gives us the experience and know-how to make our software able to function in all these different and very stringent environments and requirements. So traditionally, the way you would configure a HMI SCADA or building business intelligence system is you would have an asset that has some data sources, and you would configure a historian to start logging the data, configure some alarms, and then configure the graphics. And then when you have another piece of equipment, you have to repeat the process again and again and again. So this means that the number of steps that you have to go through for configuring an asset onto your solution is very tedious and very, very repetitive. So it's difficult to scale out when you have a large number of assets doing it this method. More modern configuration workflows would go through a process where you have the data sources, but then instead of going through the tedious steps of the historian and alarm configuration one at a time, you would define a template or a class of that particular type of equipment. And that class or template could be made up of properties of the asset or equipment, history definitions of the asset or equipment, and alarm properties of that asset or equipment. So once you have that template, you would define a definition of how many of these templates exist and where they are. There may be a hierarchical organization to that. And then associated to that template would be a symbol or a faceplate which then is used to auto-generate these graphics for the particular asset or list of assets. So this way, if you ever needed to add more assets, all we have to do is get the data sources configured on the front end, and then add to your definition of the number of instances, and automatically all the processes after that would be taken care of by some tool that will auto-generate the graphics and will update your configuration. And this allows for a more maintainable flow of configuration. And also, if you have a lot more than 5 of these assets that you need to configure, all you're adding to is the instance list without having to repeat the whole process of defining the history and alarm one at a time. So a quick comparison between the two methods of configuration. Traditionally, there's no templating, multiple steps to add a new asset, no guaranteed consistency across them, difficult to apply changes to all assets of the same type, and it's difficult to scale because you have to repeat the same steps again and again for every new asset or equipment. The more modern way of doing this is to have a template, minimal steps to add a new asset because all you're doing is adding to your definition list, guaranteed consistency for all assets of the same type because you have a template that allows you to control what goes into the definition programmatically. And it's easy to apply the changes because if you need to apply a change to assets of the same type, all you're doing is updating the template. And it's also easy to scale because you have only one location that you need to update the definition, and then everything takes care of itself through the necessary tooling and plumbing. So how does Iconics apply this modern configuration flow with our products? So the product that allows us to define an equipment template or a class is called AssetWorks. And so you can define the template of an equipment, define the properties of the equipment, history definitions, alarm definitions, and then you would define the list of instances of the equipment in Excel. So you can take advantage of all the functionality and power of Excel to duplicate and multiply and have formulas to fill in some of the tag addresses. And then we have a tool called the Bulk Asset Configurator, abbreviated to be BAC, that processes that Excel file. And then GraphWorks, which is our front-end layer, would be able to use that information that is existing in AssetWorks and multiply that out automatically by defining a symbol, and then it dynamically obtains the number of assets that it has to generate through AssetWorks, and the graphics is generated automatically. So this flow will be demonstrated later by Roberto. So now let me go through some of the features that AssetWorks has to facilitate this modern configuration approach. So AssetWorks is a way to organize your data. So you can define hierarchical structures of assets with groupings of equipment, parent-child relationships. So that way, when you need to find your piece of data, there is some organization that you can browse through that represents your infrastructure. It also allows for normalizing of protocols. So as we know, Iconics has a large breadth of capabilities in terms of communicating with all kinds of information out there through open protocols like OPC, BACnet, Modbus, SNMP, web services. All those can be brought into AssetWorks. And once it's brought into AssetWorks, everything upstream from AssetWorks don't have to know or care about the differences in those protocols because it's normalized to the Iconics protocol. And also that can be made available through REST APIs or OPC to other third-party clients that require this data. So you have single point of organization of your data stream and allows you to also swap out if you need to one protocol with another if you decide to change equipments, change vendors, update equipments. In addition to that, we can add metadata to an equipment or an asset. So as we know, the dynamic data that comes in from a device requires some contextualization. For example, where is that equipment? Who's the manufacturer? When was it produced? When was the last time it was maintained? These kinds of metadata can be added as properties of an asset, and that can be made available to any client that requires it upstream from it. And as illustrated before, we can define templates that have all these definitions predefined and use parameters to then multiply these out to multiple equipments of the same type. And that is where rapid configuration comes in. So once you have the template, it's much, much easier to then say, I have 6 of these equipments at this location. They're of the same type. I don't have to go and type in my address one at a time. I just define all that in the Excel file, and the bulk asset configurator takes care of putting it in the right locations of all the configurations and reduces mistakes that a person could make if they have to manually define all that one at a time. So an asset, as described before, contains equipment properties. One of these equipment properties can be used to perform indirect tag referencing. So we can point a property to a piece of data that maybe comes in from OPC, another piece of data of the same equipment that comes in from BACnet, and yet a third that comes in from web services, for example. And they can all be mixed together in one single definition of an asset. So you start thinking of your equipment less about the protocols that the data comes in from, but more about how it's defined as a single object that has relationships of these data points. We can bring in real-time data or data sets. We can also define disk persistent registers, like I mentioned, for the purpose of storing your metadata. You can also use it as temporary registers where you can read write to them and they will be disk persistent. So you don't lose them if you had to reboot your machine, for example. It has historian integration, so it integrates with our hyperhistorian, so you can define the definition of your tag history right inside the property definition. And it has data caching capabilities. So in some situations where your source of data is not always online, this capability allows you to have AssetWorks cache the last known data and still provide that to your clients. And then when the data source comes back online, AssetWorks will update itself. So to your clients, it is less noisy in terms of connection and disconnection. And you can also do scan rate management through the data caching mechanism so that you have a more controlled location to ensure that your backend data sources don't have to deal with many different scan rates that many different clients may have. And lastly, through the use of parameter support, these definitions can be templated and be used in the bulk asset configurator to facilitate rapid configuration. Let's talk a little bit about how AssetWorks facilitates the historian integration. So AssetWorks has native integrations with the hyperhistorian product that we have. So right in the configuration dialog of the equipment property, you would define the historian definitions, and it automatically configures the hyperhistorian, and you don't even need to interact with hyperhistorian to get the data. You would interact with AssetWorks and use the hierarchical paths and organization that you have defined in AssetWorks, and all you're doing on the client side is to tell the client to request historical data instead of real-time data. So your tag paths to get your data stay the same, and all you're changing is the context of what kind of data you're requesting. At the same time, with the same approach, we can also request data sets, alarms, or real-time data. So this could be useful when you define your front-end screens and symbols. So there's only one tag path to worry about, and you just switch the context of what kind of data you want to request on the client side. So the way bulk configuration is achieved in AssetWorks is we first define what's called an equipment class. So an equipment class can contain one or more tags with parameterized parts to the tag address or the whole address itself. So once the class is defined with the necessary properties of those class, you use Excel to define what we call a bulk configuration workbook. So in there, you define the name of the specific instance, the parent path of that instance, and the unique tag address or parameter definitions from the class that is being used to instantiate that particular asset. That whole workbook is then ingested by the bulk asset configurator tool, which then configures AssetWorks based on that definition. And if you ever need to update anything, you just either update the workbook if you want to add more equipment, or if you needed to change something about the definition, you update the class, rerun the configurator, and everything that's related to that will be updated for you. In addition to the definition of just data tags coming in or metadata of the class, we can define alarm definitions as well. So you would add the definition to the class. Again, that definition will automatically be picked up by the bulk asset configurator, and that will configure the alarm server on your behalf. And all the necessary reference and tag addressing between the asset and the alarm server is done automatically for you, and it infers the path through the definition that is in the workbook. So from a user standpoint, you really only manage the workbook, and everything else is taken care of through that definition. So this, again, reduces the area of configuration for a user and reduces the number of mistakes that could be made, and also facilitates much more efficient error checking. If something does happen to not work properly, you just go through the workbook. Yet again, because it's an Excel workbook, you can use all the Excel functionalities of finding, duplicates or typos or spelling and things like that. And it provides a much more pleasant experience through the whole process. So from a graphic standpoint, so now we have AssetWorks that has all the data defined and the alarms defined. How do we show that on the screen in a way that doesn't require manual definition of every single asset that I have? So this is where we have a function in GraphWorks called the clone dynamic. So the way it works is we have the data from AssetWorks as a data source. And in GraphWorks, we would define a symbol template. So in this case, for example, we have an asset that has two tags, tag 1 and tag 2. And we would define aliases for those tags, referencing the AssetWorks definition. And what GraphWorks does is it would ingest the data and definition of the asset from AssetWorks. It would take the symbol template, and the clone dynamic would then basically multiply the number of assets of the same type and replace the necessary tag addresses and put them on the screen, either in a wrap panel or a stack panel, and lay it out in a way that makes it all visible. So if I ever needed to add another asset, or if I ever needed to change definition of the symbol, first of all, I change the template, and the dynamic automatically updates all instances of that same type. If I needed to add an asset, I go through the bulk asset configurator process to add to AssetWorks, and automatically gets picked up through the clone dynamic, because now AssetWorks would notify GraphWorks that, hey, there's a new asset of the same type. GraphWorks then generates another symbol of the fifth asset based on the definition of the template, and your screen is updated. And all this is done without any intervention once your symbol is defined, because then the bulk asset configurator updates AssetWorks, and AssetWorks automatically instructs all instances of GraphWorks that's requesting data from it to update themselves. So very easily, again, you define everything in the workbook, and everything that ties to AssetWorks would then be updated automatically. So Roberto is going to show how some of these things materialize in the product itself. So Roberto, I turn it over to you.
Yes, okay. Let me know if you can see my screen, please, Z. Okay, I think it's up and running.
Yep, there we go.
Thank you very much. So thank you, Z. So in this demo, I will show you some of the concepts we just heard about during the presentation and explain how to take advantage of our tools to create hyperscaling applications while minimizing the possibility of introducing mistakes in your project. So we start today's demo looking at the workbench, where I have created one project where I only enabled the providers that I actually need to use for my demo. This is a nice feature that helps to focus your attention on what you really need and only that. So the provider we will be mostly working with today is AssetWorks, and the context for our demo today is in the oil and gas industry. As we have seen during the presentation, the way you work with AssetWorks is by the look like. So as an example, let me click on this one, which represents a pump. Then we have another type of pump. We have manifolds and we have station, and they all represent what we can normally find in an oil field. If I expand this asset, we can see that it is characterized by a set of properties that define its behaviors and features, and we can also define commands for each of the assets. Let me analyze one of these properties to show you an example of what Z was mentioning during the presentation. So in this case, this property is characterized by a real-time data point whose syntax is shown here, but this is not actually a real data source. It's just a templated version of it, where a parameter will need to be replaced during the instantiation process to point to an actual tag. And we will shortly see that. Just remember the name of this parameter and its syntax, it is called pump name. Under the historical data tab, we can also configure the hyperhistorian part of under hyperhistorian. The advantage here is that because you configure this only once for your abstract class, then you will get this replicated over and over for all of your instances without having to worry to replicate a similar hierarchical structure also inside the hyperhistorian. So let's look at another asset type, which is the manifold. In here, I would like to show you an example of a command. So this is a command that we would like to be executed when we click on the manifolds in our application, and we will see it shortly in the application itself. What's interesting about this command is the way the syntax for the global analysis command has been defined. As you can see here, we have a pretty common global alias string. However, there are portions of it that use a special syntax coming from AssetWorks, which allow to dynamically replace portions of this string with properties of the asset. So in this case, we would like the manifold alias to assume the name of the asset itself. This is a relative syntax to the asset definition, and you can also use it to obtain properties, for example, of the parent asset. So because a manifold will be below a station type of asset, we can access the station name by using this special syntax. What's great of this functionality is that you will not need to modify this syntax for any of your manifolds that you will introduce in your project. So the syntax will be the same for all of them. And because you don't need to change it, there is less chance that you might start introducing errors by making those changes. So it's a great way to greatly reduce the risk of introducing mistakes. So we have seen a little bit of our equipment classes, which once again are abstract representations of our assets. Now let me show you some of the real assets, which are the instances of our assets. In here we have an hierarchical tree, which I already started to populate. Later in the demo, I will also show you how to create new assets using the bulk asset configurator. But for now, I wanted to get started by looking at some instances. So once again, before we have seen the abstract definitions of an asset, this is an instance which represents a real asset out in the field. All the information that we have to provide for this asset to be created is the name of the equipment class it derives from, and then the values for the parameters that we need in order to fill in all the properties or commands for this asset. Once again, because we only need to provide these few information, there is really a small chance that we can introduce errors in this way. And to show you how these affect the properties of an instance, if I click again on the current runtime property that we have seen previously in the instance, in here, that parameter pump name has been replaced with the value of the parameter that we provided for this instance. And at this point, this is an actual tag coming from our data source. It could be OPC data, IoT data, whatever you can connect to the Iconics platform can be used in here. Okay, so we have seen enough of the AssetWorks structure for now. So I would like to go to the user interface, which we have prepared for you today. And here you have it. This is GraphWorks in configuration mode. It's a pretty standard type of application where we have some navigation icons on the left side. Then we have an asset tree for navigation among our asset structure. And here on the right side, we have used another asset tree control, but it is configured to show a list of assets along with some of their properties in the columns. So this visualization that you see here on the screen really requires very small amount of work to be prepared, because you just drop a couple of standard controls, quickly configure them. The only thing we really had to do was to tell that this control should show the child nodes of the asset we select from the tree on the left. I also have another layer that I would like to show you, which is where we have our symbols, actually symbol, because it's just one symbol. And we will use the clone dynamic to create multiple copies of this symbol. And once again, they will be generated based on the asset that we select on the left side of the tree. So let me first show you how the application looks like in runtime before we analyze how this has been done in the backend. So I log into my application, and here we are in runtime mode. All of our data has been loaded. On the left, we have the navigation bar with the icons that I mentioned before. In here, we have our stations and manifolds. And on the right side, we have all of our assets, which are dynamically generated by the tree control. So we will have one row for each child node of the selected asset in here. So if I click on a different manifold, this list will be upgraded and refreshed to show the list of assets. In this case, we have a little less than we had before, so this list can dynamically expand or collapse based on our needs. Now let's go to the other layer where we have our symbols. So that symbol that we have seen in configuration mode where we only had one, as you can see now we have multiple copies of this. And the good thing is that we can also associate commands to them. So for example, I can click on these to visualize some of the historical data that we are logging using Hyperhistorian configured through AssetWorks, as we have seen in the Workbench configuration. And if I click on a different asset, of course, we will be looking at a different set of data coming from another asset. All of these symbols have been generated automatically using the clone dynamic in GraphWorks. So let me show you how that works in GraphWorks configuration. So in order to get to the symbol, I have to expand a little bit my structure here. And here we are in the pump symbol. If you are wondering why we have so many containers for this symbol, it's because they allow to implement the layouting we need in order to obtain what we call the responsive layout, so that if you reduce the size of your screen, the symbols are arranged vertically, we have a scroll bar, and we can go up and down, and if we maximize it again, they rearrange themselves to use all the available space. So back on our symbol, as I mentioned before, the way that we replicate this symbol is by using the clone dynamic, which I can select from the dynamics tab over here. The clone dynamic is pretty simple but powerful. We only have to provide it a couple of things. The first one is the number of items that we would like to generate, so the number of items that will replicate the symbol. And for this, we use a special property that every asset has in AssetWorks, which is the number of child nodes for that specific asset. What's interesting in here is that the name of the asset that we want to analyze is dynamic and depends on a couple of global aliases that, if you recall, we set when we click on the manifold. The command has been configured from the workbench. So when we click on a different asset, this value here, which is a number, might change, and therefore GraphWorks will regenerate the appropriate number of symbols here. The other property we have to define is this one called instance. This is the name of the iterator or the counter that we will be using inside our symbols. It's just a number going from 0 to the number of children of this asset minus 1. So the first one will have index 0, then 1, 2, 3, 4, 5, and so on. So how do we use these in order to get the data values that we need inside the symbol? Let me show you an example of one data source that we have inside our symbol. So let's take the pump name, which is shown up here at the top. The pump name is retrieved through this expression, which I will show you inside the expression editor in the data browser. This expression is using another special property that every asset has, which is an array containing the names of all the child nodes of an asset. So once again, we have the manifold that we select from the left tree, and here we have an array containing all the names of the child nodes. Instance will be the index that we said before, from 0 to number of child nodes minus 1, and this function getAt is simply getting the element with this index number from this array, and that will be the name of the pump that we have seen in the application. A slightly more advanced example can be seen in this color dynamic, which is used to change the color of the name of the pump based on the status of that pump. And once again, let me open the expression editor to show you how this expression looks like. In this case, this expression is used to build the syntax of the point name for which we need to retrieve the value. Because this is a point name coming from the asset catalog, it starts with AC. Then we have the name of the station, the name of the manifold, and then this is the same syntax we have just seen from the process point, which will return us the name of the pump, and then we have the name of the property. So what this expression does is to return us a string, which represents the data point containing the value we want to retrieve, which is made up by station, manifold, pump name, property name. However, we don't need the string containing the name of the tag. We need the actual value of the tag. And in order to retrieve that value, GraphWorks has this checkbox at the bottom, which allow us to do exactly that. The way this is implemented in GraphWorks is by prefixing the value of keyword in front of your expression. So the expression returns a string representing the point name for which we want the value. In this way, we can obtain exactly what we have seen in this application. So the first element will have the name of the first asset and so on. And for those that have a specific state, the color will be changed thanks to that color dynamic. Okay, we have seen enough of this from GraphWorks. The last thing I would like to show you is how to add more assets to our hierarchy over here. And to do so, as Z mentioned, we will be using a tool called the bulk asset configurator. The bulk asset configurator is a fairly simple tool, but extremely powerful, which will save you an enormous amount of work by using it. It has a few properties, and normally you can just leave the defaults, but you can tweak them a little bit based on your needs. The only thing that you really have to specify is the name of the Excel workbook that you want to provide that contains the definition of your assets. So let me show you an example of such a spreadsheet. This is an example of it where every line in this spreadsheet represents one asset that we want to create into our workbench hierarchy in the AssetWorks provider. The way to read this is taken a line, is that we want to create an asset in this path. You can think of it as a folder if you want. So it will be into this station under this manifold. This will be the name of the asset, so BP0380. This is the class this asset has to derive from, and these are some of the values for the parameter. You may remember that we had pump name parameter in the workbench before, and in this case we are using this value PMP0097, which will point us to the correct asset in our data source. Okay, once we have seen this spreadsheet, we have a few hundreds assets in here, which we will be adding now using the bulk asset configurator. All we have to do is just to click on the execute button and the process will start. Now, I'm only adding a few hundreds assets because I didn't want you to stare at that green progress bar for the rest of the webinar, but the process would be the same if you had to add thousands of assets. And the good thing about this is that by using an Excel spreadsheet, you can have your customers or your end user fill it in. They don't need to have any knowledge of the Iconic system. As long as they know the information they have to provide, anyone can fill in that Excel spreadsheet, and all you have to do is to click the execute button, and the process is done in a matter of a few seconds. So let's go into the workbench to see if these had the result we expect. We still have only one station in here, but if I refresh the asset tree, we should see now that we have a couple more stations added with their manifolds, with a lot of pumps in there. And in here we have the one that we have analyzed from the Excel spreadsheet, which is BP0380. And if we go under the instance detail, we will see that we have the value for the parameter that we have seen from the Excel. So everything seems to be generated correctly from inside the workbench. Now let's go and see how these affect our application. So as you can see, we still only have one station in here, but if I right-click here and do a refresh of the asset tree, also GraphWorks will immediately receive the changes and show us that we have more stations, more manifolds, and we can click on them. The symbols will be generated. We can go also under the tree view visualization as a list, and all of the data will be there. We can also click on them to visualize the historical data, of course, because we just started to log them, because I actually created them just now. We don't have much data yet, but if I reduce the period, you can see that some data is starting to accumulate on this part of the screen. So just to recap what we have seen from the workbench, we have seen how to define abstract representations of your assets, how to instantiate them quickly using the bulk asset configurator to quickly create your hierarchical structure with very small chance of introducing errors. And then we have seen a couple of ways in GraphWorks with which you can create dashboards by pointing to the data provided by AssetWorks with minimal effort. This concludes our demo today, so let me turn it over to Amanda, and thank you very much.
Thank you very much for that informative presentation. Let me switch to my screen here and show you my conclusion slides. Okay, and now I'd like to talk to you about the Iconics Worldwide Customer Summit Transform 360. We recently rescheduled this in-person event to May 4th through 7th, 2021 at Foxwoods Resort and Casino in Connecticut. If you already signed up for the event and you'd signed up for the previous dates, we've just moved your registration already to the new dates, so no action needed on your part. If you haven't already signed up, I encourage you to do so. This event is going to be bigger and better in 2021. We have a number of exciting guest speakers lined up, as well as compelling demos to show you. If you register by April 19th, you can do so at iconics.com/transform360. We have a number of promotions that we put up on our social media pages from time to time, including complimentary registration promo codes. So I encourage you to follow us on social so you can see those and sign up. I really hope to see you all there at this live in-person event. I'd also like to share with you a number of on-demand webcast recordings that we have available at iconics.com/webcast. If you've enjoyed today's webcast, you can see the other topics that we have covered this year. And not only do we have these North American webcasts, but we also have a number of international versions as well. And while I'm answering some of the questions that have come in, I'm going to leave this slide up here so that you can get our contact info for our presenters today, as well as some contact info for various solution salespeople that are in our North American and international offices. And with that, I'm going to start taking some of the questions. And so let me start with the first one here. This one I'm going to direct towards Roberto. So Roberto, this question is for you. If I choose to create the history tag instead of the asset class property, does that mean I no longer need to set up the history definitions tab in the back spreadsheet?
Yes, that is correct. So basically you have AssetWorks, which is going to generate the historical tags for you, although you can still use other ways of configuring historical tags directly inside of the hyperhistorian for those tags, for example, that do not belong to an asset, but you still want to log into the system.
Thank you, Roberto. Next question I'm going to direct towards Z. Can we add an asset to the application without shutting down rebooting the SCADA system?
Yes, that is correct, because all we're doing is referencing the data source. We're not affecting the data source itself until everything is configured and a client requests to change a set point, for example.
Okay, thank you, Z. Next question I will give to Roberto. Is it possible to multi-select properties of an asset to copy and paste?
Yes, absolutely. You can do that. You can even copy the whole asset itself if you want, and eventually remove those that you don't need, but it's certainly doable.
Thank you. And next question I'll give to Z. Are the graphics generated in 3D formatting?
The graphics, at least the ones that Roberta showed, are not in 3D formatting, but you can also use the same methods for 3D graphics in the 3D viewport of GraphWorks.
Okay, thank you, Z. Next question for Roberto. Is this tool using the graphic generating tool for graphics generation? Hopefully I'm asking that right.
Not the one that I showed today. This one is using the power of the asset navigator control to generate all the information you want, and the symbol that you saw on the other layer was simply replicated using the clone dynamic at runtime, so no other tool was used to generate that graphic.
Okay, thank you, Roberto. Another one for Z here. Is there an additional license to use AssetWorks?
No, AssetWorks is included as part of your Genesis 64 license purchase.
Okay, great. Next one is for Roberto. How do you configure alarm definitions in AssetWorks templates, i.e. equipment classes?
So in order to do that, you still rely on the tab in the workbook as you were doing before. The interaction right now with historical data can be done at the asset level, while for the alarms, you can still rely on the other way that you were using before.
Okay, thank you, Roberto. Next question is for Z. Does AssetWorks, is AssetWorks a replacement of UDM?
It's not a full replacement as of yet. It's has similar aspects to UDM in terms of defining expressions in a centrally located location. It's more of an evolution, if you will, and UDM is going to be sunsetted soon, and AssetWorks will at some point take on all the functions that UDM has. But as of now, both are still available, but we are promoting AssetWorks as the place to do a lot of the centralization of configuration.
Okay, thank you, Z. I'm only going to take one or two more here. This next one is for Roberto. If you configure the historical tags in AssetWorks, do you still need to have Hyperhistorian?
Yes, you are just using, let's say, a shortcut to configure your tags directly from AssetWorks, which allow you to have the power of automatically replicating your assets without replicating the structure in Hyperhistorian. But Hyperhistorian is still doing the job in the background, so you will still need to have Hyperhistorian as a product.
Thank you, Roberto. Last question here so we can wrap up in our time limit. This will be for Z. You can wrap things up for us. What version of Genesis 64 do I need to get these features?
The features that Roberta has shown is available starting with 10.96. Some of those are already available with 10.95, but a lot of like the Hyperhistorian integration with AssetWorks is only available starting with 10.96.
Okay, thank you. And with that, we're going to wrap things up for today. So I'd like to encourage you all to register for more of these webcasts at iconics.com/webcasts. And I'd like to thank you all for taking the time to join us today. And thank you, Z and Roberto, for a great presentation.